For just a straight pressure vessel, you have stress like that.
Mm-hmm.
But this isn't just a straight pressure vessel.
It's circular. Or are we just looking at like a piece on the outside, pretty much?
Well, so if there was just a pressure vessel and these loadings weren't here, our stress would look like that.
Right.
Is that familiar?
That's a square.
Yeah, this is a stress element though.
Okay.
Because like you said, we have the radial or the tangential stress, PR over T,
Mm-hmm.
and then the PR over 2T. That way. So if we pulled out a little chunk,
That's what you're looking at right there.
that's what I'm looking at.
PR over 2T. Then we have PR over T. Okay.
Now, on top of, so the hoop stress is going this way. That one's kind of by itself. The normal stress going this way also has the 200.
So we could if I'm twisting this, I'm imagining that the 240 pound inch is like a shear stress on the outside of it.
If you remember, internal torques create shear stress.
So that's what that is. We're just gonna say that that's acting down and up.
Yeah, so we'll just say that right there is the value of TC over J. And we'll calculate it in a second.
Well, don't we already have it?
We have the torque, we don't have the stress.
Oh, okay. And that's gonna be a negative number.
It won't matter much.
Okay.
So that's, the 240 is creating shear stress on our stress amount. And then the 200 is acting in
That direction.
conjunction P over A.
Okay. And then going up, does the 240 also act on that?
On this?
Yeah.
The 240?
Yes.
The 240 only creates shear
Only
stress.
crust. Okay, I was just wondering that. Then the 500 has to do with the PR over T then.
Yeah, so that's gonna put both of these.
That's both of those already.
Uh-huh.
That's the pressure times the radius over the
thickness.
thickness. Okay.
Yeah. And so the 500 is causing those. The 200 is adding to the stress already from the pressure vessel. And then the 240 is causing some shear stress.
Well, we already have everything then.
We gotta calculate our values.
I know.
So let's calculate them.
Okay. So P. Which one do you want to do first?
We'll
P
start
R
there.
over T. So that's gonna be. We're using the 500 for that one, right?
Yeah.
Okay. 500 times our radius, which is which one are we using? Are we using the 0.55 minus 0.5?
The inner radius is what you use.
Okay. It doesn't matter about the other one.
No, because these equations are set up for inner radius.
Oh, sweet. Okay, that's why they only give us the inner radius.
Yeah.
Because we don't actually use it unless we're trying to calculate area.
Yeah.
That's the only time we use it. Sweet. Alright, so PR and then the thickness is 0.025. Times 0.5 divided by 0.025. I got 10,000. Is that right?
Your 0.5 is your diameter.
Oh, right. Thank you. That makes a difference.
That'll make a difference.
5,000. PSI. Okay. And then PR over 2T divided by 2 times 0.025 is 2,500.
Mm-hmm.
Okay. Awesome. And then we need to figure out our TC over J is.
Did you add on the P over A?
Yeah, P over A, okay. So P over A is gonna be, we're doing the 200 pounds for that one, right?
Uh-huh.
So the 200 divided by our 0.041. So that's 4878 PSI. Okay, awesome. And you got that number.
When you add them together, you should get that number.
Yeah, which is equal to 7,378 PSI. Okay.
Now we can do our TC over J. And remember here, the C term is the outside radius.
Because it's acting on the outside.
Yeah.
Okay. And then so is the J. When we calculate J.
Well, yeah, for the J, you're going to have to
do the whole thing.
The minus.
Okay. So I just want to see that written out. So that's going to be our TC over J, which is going to be our 240, right?
Mm-hmm.
Times our C, which is our outer radius, or outer diameter, or outer radius, so it's going to be what is 5.5 divided by 2? 0.55 divided by 2 is 0.275. And then over J is pi over 2, because I like using that one, of 0.275 to the fourth minus 0.25 to the fourth, right? Yes. Okay. And I got 23176.
Yeah.
.7, so 237 PSI. Just round that up.
What'd you get?
I just did 23177 instead of 176.7. It's the same thing.
Cool.